Hi everyone, today we are going over 3.2, so Unit 3, Day 2, and this unit is all about this section is all about factoring in the quadratic formula. Now, hopefully you guys remember that in Secondary Math 2 last year, you learned how to factor and do the quadratic formula, so hopefully this is all just a review, but if not, that's why I'm going over it. So first I just want to point out what solving quadratics means. To solve a quadratic means to find the X intercepts. These are also called the roots or the zeros of the quadratic. The X intercepts are the values of X where the graph crosses the X axis. So for example, if you had a graph with like a parabola, okay, right here where we cross the x-axis and right here where we cross the x-axis, those are our x-intercepts, also called the roots or the zeros. So just know there's a lot of different terms you can use for that, okay? Okay, so one way that we can solve quadratics is by factoring. Factoring, you learned all about polynomials last time. Remember, factoring is a method of expressing the polynomial as a product of its linear factors. Now, since we are factoring quadratics, hopefully you remember that quadratics have x squared. So our highest degree is this exponent of 2. Factoring allows us to simplify quadratic expressions, find their roots, and solve equations. Helps us find the zeros, which we just talked about, of the quadratic equation when we have it in standard form as ax squared plus bx plus c. So let's go over an example. Right here, number 1, we're going to solve the quadratic by factoring. So the first thing we need to do before we can solve it is factor. Now, when you factor, you have to think what two numbers multiply to give you 8, but add to give you 9. So there's a way that I like to organize this. I like to do a big X. And 8 is going to go at the top, and 9 is going to go at the bottom. Now, I want you to think what two numbers multiply to give you 8 and add to give you 9. Well, 1 and 8. 1 times 8 is 8, and 1 plus 8 is 9. So when we write this in factored form now, it's going to become x plus 1 times x plus 8. Hopefully this is like coming back to you guys from last year as a review. So we can see here that we wrote it as a product, right? The polynomial, aka this quadratic equation, as a product. And so now we're going to solve it. So we're going to set this equal to 0, okay? So essentially you're going to split these up. You're going to do x plus 1 equals 0. And x plus 8 equals 0. And then you're going to solve for x in both of these. Now, the reason we split them is because any number times 0 equals 0. So if our x plus 1 is equal to 0, then this 0 times whatever x plus 8 is equal to 0. If x plus 8 is equal to 0 right here, well then whatever x plus 1 is times 0 is also equal to 0. So that's why we split them up and set them equal to 0, because anything times 0 is 0. So right here you'd subtract 1 from both sides, so you'd get x is equal to negative 1 and x is equal to negative 8. So there are two solutions, which makes sense because this is not an exact graph, but it'd be a parabola going up, so it would hit 2 times, okay? Okay, we're gonna keep doing some factoring problems. Main things I want you to take away from this slide. You have to think, what 2 numbers multiply to give you this, but add to give you 9? I like to organize it by using this big X. You put the C term, as in like ax squared plus bx plus c. You put the C term at the top, the 9 on the bottom. 1 times 8 is 8. 1 plus 8 is 9. Now the reason you don't go for the addition first is because there's so many ways to get to 9, right? 1 plus 8, 2 plus 7, 3 plus 6, 4 plus 5, and so on and so on. Well, there's only a couple ways that you can multiply 2 numbers to get 8, and that is 1 times 8 and 2 times 4. So a lot simpler. That's why we always think first what multiplies to this number and then adds to the bottom number. Okay, let's do some more examples. Okay, number 2, we have x squared plus 10x plus 24 equals 0. This is in standard form. We don't want standard form, we want factored form, and we're going to solve the equation once we factor it. So you have to think what 2 numbers multiply to give you 24, but add to give you 10. Well, let's put 24 in our big X, play some X games, 10 down here. Okay, then you'll think, what 2 numbers multiply to give me 24, but add to give me 10? In this case, it's 6 and 4. If you write 4 and 6, that's totally okay too. Doesn't matter what order it goes in, okay? So now, with the 2 numbers that we got on the side of our X, we're going to put them into parentheses. X plus 6, X plus 4 equals 0. That's a parentheses. So now, we're going to split up our parentheses to solve by factoring. So we're going to put x plus 6 equals 0. Because if we got this to equal 0, then 0 times whatever ended up in this parentheses would equal 0. Okay, and then x plus 4 equals 0 for the same reason. Okay, so you get x is equal to -4. Boom. So good. And over here, x is equal to -6. So we have 2 solutions. That means that on our X intercept, our parabola hits at -6 and -4. Okay, next one. X squared minus 2x minus 15 equals 0. This is standard form, but we want it in factored form. So we're going to factor it by thinking of 2 numbers that multiply to give you 15, but add to give you -2. So we're going to have some negative numbers in this one. So far we've only done positive. So -5 times 3, let's try that. -5 times 3 is -15, and -5 plus 3 is -2. So when we write this in, since this is a -5, we put x minus 5 times x plus 3. Equals 0. Okay? If you want, you can write it out. X minus 5 equals 0, x plus 3 equals 0. Or maybe you can just tell right off the bat that x is equal to 5. Because if we plug 5 in here, 5 minus 5 is 0, right? And x is equal to -3, because if we plugged in -3 to this one, it would equal 0. And this one, it would equal -8. Well, -8 times 0 is equal to 0, so that checks out. That works. Next one, we have standard form. We got to put it into factored form, so I'm going to use a big X. So I have -32 on the top, 14 on the bottom. Okay, let me think. 32, 8 times 4, that wouldn't work. This is going to be 16 times -2. Because 16 times -2 is -32. And 16 plus negative 2 is a positive 14. So I get x plus 16 times x minus 2 equals 0. So we can figure out that x is equal to negative 16 and x is equal to 2. Boom. Right there. Okay, last one. This one's a little different. Do you notice that we don't have a middle term? So on all of these, we had a term with just x by it. Well, this one's just x squared minus 16. So we can still make our big X. We have to think, what two numbers multiply to give us negative 16 and add to give us 0, because there's no middle term, right? There's no B term. So whenever you have 0 down here, you're going to have a positive number and a negative number that match. So in this case, we have negative 16. So we're going to have a negative 4 and 4. Because negative 4 times 4 is negative 16. And negative 4 plus 4 is 0. So x minus 4 times x plus 4 equals 0. So if we were to split these up and solve for x, we'd get x is equal to 4 and x is equal to negative 4. Oh, there we go. There it is. Okay, so that is factoring. Hopefully that's coming back to you, because we're going to move on. Can you solve x squared minus 10x plus 6 equals 0 by factoring? Okay, well, we just did factoring, so let's check. We're going to put 6 up here and negative 10 down here. Okay, let's think. How can we multiply to get to 6? We have 1 times 6, or 2, that's a times sign, not a plus, or 2 times 3. And those are really the only ways to get to 6, right? Well, 1 times 6 is 6, but 1 plus 6 is not negative 10. 2 times 3, yeah, that's 6, but 2 plus 3 is not negative 10. So this one cannot be factored. No, cannot be factored, because no two numbers multiply to give you 6 and add to give you to negative 10. So what happens when you can't factor? Well, you have to do the quadratic formula. Okay, quadratic formula. We can solve for the roots of a quadratic equation by using the formula that's listed there, where a, b, and c are numerical coefficients given in standard form, ax squared plus bx plus c. So these b's, a's, and the c, you fill them in with the coefficient from our standard form, okay? So our a, b, and c terms. Now, you do need to memorize the quadratic formula. You did it last year. Hopefully you can do it again. Some of you might have learned a song like x is equal to negative b plus or minus the square root of b squared. I don't know. Whatever that song is, okay? I don't teach it that way. I teach it a little differently. So I always say, there once was a negative boy. He was unsure if he wanted to go to a radical party. He decided to be square and missed out on dancing with 4 awesome chicks. The party was all over at 2 a.m. Okay? So, memorize this quadratic formula, because factoring doesn't always work, but the quadratic formula always does. So, when you use the quadratic formula, these are like the 4 steps that you're going to follow. You're going to get the equation in the form of ax plus bx plus c equals 0. So essentially you need one side to equal 0, okay? This one does not equal 0, so let's do that first. So we're going to have our original problem, which is 2x squared plus 5x equals 7. Okay, so First step, get the equation in the form of ax squared plus bx plus c equals 0. Well, we have ax squared plus bx, but then we have equals 7, not equals 0. So we need to bring the 7 to the other side by subtracting it. Now, this 7 is not like terms with anything over here. So when we rewrite it, it's just going to be 2x squared plus 5x minus 7 equals 0. Okay, step 2, we need to identify the coefficients a, b, and c. So a is going to be whatever number is in front of our x squared term, okay? In this case, it is 2. B is going to be whatever number is in front of our x term, which is 5. And C is going to be the number that's alone, which is negative 7. Okay, now we need to remember what the quadratic formula is so that we can substitute the numbers that we get for A, B, and C into the quadratic formula. So remember, we have a negative boy who is unsure about going to the radical party. He decided to be square and missed out on dancing with 4 awesome chicks. And the party was all over at 2 a.m. I should say that that is equal to x, okay? Okay, so we're going to take this stuff right here, our A, B, and C, and we're going to plug in wherever there is an A, we're going to plug in 2. Wherever there's a B, we're going to plug in 5. C, negative 7. So let me change back to my pen color. Okay, so negative B. So we put a negative, and then whatever B is, we fill in. So it's just a 5, so we're just putting in 5. Okay, then we have plus or minus the square root of B squared. Well, B is 5, so 5 squared minus 4 times A, which is 2, times C, which is negative 7. All over 2 times 2. Okay, now when you have this, you're just going to simplify. So we have negative 5 plus or minus the square root of 25. Then we have a negative 4 times 2, which is negative 8. Negative 8 times negative 7 is a positive 56. All over 2 times 2, which is 4. Okay, so let's simplify that a little further. We have negative 5 plus or minus the square root of 81 all over 4. Okay, well, we need to simplify the square root of 81. This one is a perfect square, so we're going to get a whole number. The square root of 81 is equal to 9, because 9 times 9 is 81, okay? All over 4. Now, we have negative 5 plus 9. So negative 5 plus 9 is 4, so we're going to have 4 over 4 for 1, which 4 divided by 4 is just equal to 1. And then we have negative 5 minus 9, which is negative 14 over 4. Now, 4 doesn't go in perfectly to negative 14, but we can simplify it to negative 7 over 2. Okay? And those are our 2 solutions. So, remember these steps. You have to set one side equal to 0, okay? Identify A, B, and C. Plug them into the quadratic formula, and then you need to simplify. Be really careful when you're doing that, because it's easy to make a mistake, but you can do it. You can do hard things. I'm going to do just one more quadratic one. We'll just do this one up here, okay, number 8. So first thing I need to do is I need to get one side equal to 0. So to do that, I'm going to have x squared plus 4x. To move this positive one over, I subtract 1 from both sides. So if I do that, then this side would equal 0. And now I need to identify A, B, and C. So A is equal to 1, B is equal to 4, and C is equal to -1. So if there's nothing in front of the x squared, it's 1, okay? Okay, now we need to substitute it into the Pythagorean, wrong formula. The quadratic formula, okay? So we must remember that this is the quadratic formula. Okay, so now we're going to substitute our values in. So we have negative b. Well, it's going to end up being negative, and then our b is 4 plus or minus the square root of b squared, which is 4 squared, minus 4 times a, which is 1, times c, which is -1, all over 2 times a, which is 1. Okay, so that's going to simplify down to -4 plus or minus square root of 4 squared is 16. What's the square root? 16. -4 times 1 is -4, and -4 times -1 is a +4. All over 2 times 1, which is 2. So then we get -4 plus or minus the square root of, this is going to be 20, all over 2. Okay, we can simplify this radical. So 20 can break down into 5 times 4. This just breaks down into 1 times 5, so we don't need to expand that anymore. 4 times 4 is 4 is 2 times 2. Well, there's a pair, so that comes out of your square root. So the square root of 20 is the same thing as 2 of the square root of 5 over 2. And there's your answer. Okay? Good luck. The notes answer key should be on Canvas for you. But please reach out to your teacher or go to the math lab if you have any questions. Thanks.